All right, hey everybody, welcome back. Today we're going to talk about vineyard nutrient management. And if you would like a resource to this presentation, check out chapter 16 from the Grape Growers Handbook. It's a little bit, it's a different textbook than the new viticulture textbook that I have been using for this class. The Grape Growers Handbook is written by Ted Goldammer and very great resource. I pretty much outline most of chapter 16 in this presentation. So yes, if you'd like to read it, I would highly recommend it. Okay, so we talk about nutrition, right? Nutrition is very important. Think about for a plant, think about for us. You know, we often take multivitamins, things of micronutrients that we need that we don't get in our day-to-day diet, whether it's by, specific choice of lifestyle or we are just too busy and we just don't eat enough of the right things. We all need nutrients for our bodies to function properly. So plants are no exception to that. And just like we are all different and we all have different needs and requirements for our health, every vineyard is also different too. So there is no such thing as a one program fits all approach to vineyard. So that's why we talk about nutrients. We're going to talk about sampling and the different ways that we can tell how the health of the vineyard is doing, basically. So nutritional program will depend on the grape variety itself, the rootstock, the age of the vine, the soil type, your water and irrigation supply, your production and wine quality expectations, and also your management history. All these things will impact what type of nutritional program you need for your vineyard. So overall, vines require both macronutrients and micronutrients. Macronutrients include nitrogen, phosphorus, potassium, and magnesium. And then micronutrients include boron, zinc, and molybdenum. Sorry. That was a tongue twister. Okay, so determining soil nutrition, there's 3 different ways to determine the nutrition. One is visual observations, right? This is, if you have plants at home, this is probably the first thing that you see that you relate to for determining if your plant is unhappy. It'll look wilted. It'll start showing colors that it doesn't normally show, damage from insects or other things. So visual observation is definitely one of them. 2, we have soil analysis, which we just did a presentation on the basics of soil. So we'll learn more about how the texture and the cation exchange capacity affect nutrition. Then number 3 is tissue analysis. And this is where we take samples of the petiole or the leaf blade and we actually send it into a lab and see what nutrients are present, the flow of these nutrients, and whether or not we need to add more of these to the soil to help the vine grow at certain stages. So the big picture is all 3 of these are important for determining the soil health and diagnosing issues in your vineyard. So you can't just rely on visual or soil. You actually need all 3 and they all play together into creating a correct diagnosis for what your vineyard needs. So I want to take a multi-step approach. So 1, visual observations. So pretty straightforward. These are things that you will be able to see, right? So it's important that you inspect the foliage for symptoms of nutrient deficiencies. That you're also looking at vine vigor and crop size. So if your vine is just having a hard time growing and it's showing very small leaves, very stunted growth, or all of a sudden it's not producing hardly any fruit at all, you could be looking at a nutritional deficiency. So some of the symptoms you might find are chlorosis, which is yellowing, which we have with this first image right here. You could also, like I said, have stunted growth of shoots. So all your shoots, the nodes of the shoots are very close together. The leaves are very small. It's having a hard time just expanding and growing as beautifully as it normally does. You also have necrosis of the leaf margins. So necrosis is just cell death. It can happen in plants. It can also happen in people as well. So these dark spots that you're seeing in between the veins of this leaf, those are dead cells. So that is not a good sign. The plant is not doing well, and there's definitely a nutritional deficiency there. Another thing could be irregular fruit set. So we talked about hens and chicks in this class, how that could be like a boron deficiency. There could be a hormonal situation happening there. Another deficiency there. Small berries, and so on. So that's just a short list. It's non-comprehensive about what could potentially show visually what's wrong in the vineyard. Interestingly enough, too, the position and the age of the leaves that are showing symptoms on a given vine can also indicate what kind of deficiency it is. So definitely make note of that if you're going to try to research something that might be wrong with your vines. The age of the leaves and the position makes a big impact on what it could be. It's also hard to diagnose what can be wrong with your vine with just visual observations, because it could be a compound of multiple deficiencies showing in the vine, but it could also, foliar symptoms also are caused by herbicide toxicity or insect infestation. So there could be a couple other things that are, harassing your vines, but just take notes of what the symptoms that you have and the positions and the age of the leaves, and you should be on the right track. So talking about how we can determine what type of deficiency we have depending on where it shows on the vine. So we have certain elements that are very mobile and certain elements that are not very mobile. So the ones that are mobile will show themselves the most on older leaves. And then we also, like the elements of nitrogen, phosphorus, potassium, magnesium, sodium, and chlorine will show up in old leaves. Manganese will show up in young and mid-stem leaves. Then we have, sulfur, iron, copper, zinc, molybdenum. Those will show up in younger leaves. So like the newer, fresher growth, you'll see a stunt in that. Then we also have calcium and boron, and they'll show on the young leaves in the growing tip. So one of the greatest limitations to relying on visual deficiency is that the problem has already occurred and already affected your fruit for that vintage. So that is kind of a bummer. And that's where the different other types of testing comes into play. But by the time that you see it on your vines, it's already an issue and it needs to be addressed, basically. Kind of a fun fact, that's one of the reasons that roses are planted at the end of grapevines, like vineyard rose, is because roses can be an indicator plant for disease or bugs that are about to attack your grapevine. They'll attack the flower. They'll attack the rose bush first before they attack the vine, so that could be a good indicator. But oftentimes they're very romanticized because roses and vineyards are just naturally romantic things. Okay, so that is a quick snapshot of the visual signs of deficiencies in vines and like some of the things that could be potentially a problem depending on where your deficiency symptoms appear. Next, we have soil analysis, and we just did a whole presentation on soil, so at this point you guys should be experts on the basics of soil and compaction and aeration, all those wonderful things, right? So the type of soil that you have can reveal what is potentially available to the vine as far as nutrients, but it doesn't actually show the real relationship between the soil and the vine in an established vineyard. So just because your soil has all these nutrients in it doesn't mean that the vine is actually utilizing them and uptaking them the way that it should be. And a lot of that can be because of imbalances in pH. So just like the pH, you take the winemaking class, right? We talk about pH a lot for an ideal range for yeast and bacteria to operate and to metabolize all the things they need to and perform as they should. Just like the pH, of our blood, the pH in our body, and the pH of a fish tank, the comparisons go on and on, but soil is also not an exception to that, right? So soil needs to be within a specific range to make these nutrients accessible to the vine where the vine can actually utilize them. So soil analysis kind of helps give us the idea of what's potentially available, but there can be problems, right? You want to be looking for issues of chemical imbalances, salinity, cation imbalances. So you'd be looking at magnesium, calcium, potassium for the majority of those, and also an excess of boron would be a huge problem as well. So turning in a soil sample into a lab can give you that information and they'll tell you where the ranges that you should be and if you are, out of bounds on any of those ranges. The downfall of soil analysis is it's not always a complete representation of like we said, what goes on in the vineyard, the relationship, but it doesn't always represent the entire depth of soil and root interactions as well, because we take soil samples fairly close to the surface, and we can take them deeper on too, but the roots of a grapevine actually penetrate so far deep into the soil that it's really hard to get the complete picture, so it's difficult. The only way to understand the best way to determine which nutrients are present in the vine is actually through plant tissue analysis. So soil analysis will tell us what is available in the soil, but the plant tissue itself will actually show, hey, this is what the vine is actually taking up into its system and what's available for the vine to utilize for growth. So that's why plant tissue analysis will be so important. But you need all three to really get a good view of what's going on in your vineyard. Cool. So if you send in a soil for lab analysis, this is a fantastic table I took from the textbook. And this just shows you the reporting symbol of these wonderful things and the reporting units as well. These are things that you could be looking at, right? And then we have another table in the next chart that will tell you the desired ranges for these measurements as well. So, and I'm sure the lab would provide this for you too. So if you're going to be serious about taking soil analysis, it's really important that you use the same lab. Depending on the method of measurement from the lab you're sending to, you could get different answers. It doesn't mean that one is necessarily wrong. It just depends on their method of measurement. So use the same lab. Also take multiple samples from within your block. Don't just take one sample from the center of your block, right? Or one sample from the side of the road. Take multiple samples to get a statistically representative area of the soil. But also, if you're going to be doing this measurement once a year, or if you planted brand new vines, you're going to be doing this every year for the first 4 years of development, make sure you're sampling from the same areas. So you could either flag a part of the vineyard or designate certain rows for soil samples, whatever helps you remember best. Make sure you're doing it from the same areas so that way you can get consistent results, right? Because soil and nutrients can be so variable in the vineyard. The best shot you have actually tracking and making sense of all that data is to be as consistent as possible. So it does matter. So you can take 2 samples at different depths. The first one would be from 0 to 8 inches, and the second sample will be from 18 to 24 inches. So 24 inches is a pretty good depth of soil, but like we said, 24 inches does not capture the whole depth of the soil and root interaction. So it's a good snapshot, and a lot of the organic matter and nutrients are in those upper layers, but it's not a whole representation of what's going on. Cool. For the most part, it's important to note that soil nutrient content does not rapidly change for most nutrients. Like your soil is what your soil is. And that's the exception for that would be unless you make very large amendments to your soil. So if you're adding a bunch of lime or a bunch of gypsum and you're ripping the soil to change the pH deliberately before you plant a vineyard, then yes, things are going to change dramatically. But for the most part, things don't change that much. So sampling is only really required every 2 to 5 years in the fall or the early spring. Cool. Awesome. It's also really important to do soil analysis before planting a vineyard. It would be great information to know before you drop a huge sum of money on a project, or especially if it's a business that your livelihood depends on. You're going to want to know everything that you're getting into, right? So you can't just, even if you had endless money in the world, you want to make sure that you're making a good decision for the health of the vine. So it's important to know. So with this analysis, you could find out if you have to make any large amendments, like adding gypsum or lime, right, to acidify or deacidify your soil. Predict also fertilizer requirements, so you could have an idea of wow, I have super sandy soils and it retains 0 water and 0 nutrients, so I'm really going to have to choose vines and rootstocks that will be successful in that area. But also here is my game plan for our nutrients and my irrigation system and everything else, because those are so hugely affect your cost of your operation, right? So it's very important. It's also important to know if you need to make amendments before you plant, because making amendments to soil is a lot easier before you have a bunch of plants in the way to work around. So if you need to do any ripping and getting those amendments into the soil, those ameliorations, it's good to do that before the plants come in. If your plants are already there, your only option after that is to do a surface application, which can be difficult, but it is possible. And then, predict fertilizer and irrigation requirements, right? So very important that we know these things. Cool. So soil pH. So as we were saying, the pH of the soil is extremely important because it affects the availability of these nutrients for the roots of the vine, right? So soil pH affects mineral solubility and availability for the vine. Optimum soil pH is between 6 and 7, so neutral to slightly acidic. If you're at a very low, like extreme pH, your beneficial elements such as molybdenum and phosphorus, magnesium, and calcium become less available. But on the other hand, you have other elements like aluminum, iron, and manganese become more available and possibly at toxic concentrations. So really not ideal. You want to make sure that the good elements are in play, the pH is within a healthy range for the vine, they can utilize what they need, and that the elements that they don't need so much of remain in smaller availabilities, right? So here is a really nice chart showing us between 6 and 7 what elements are available to plants in soil in that pH, and how those values change depending on which way we go on the scale of pH, right? So we go more towards acidic, we have huge amounts of iron, larger amounts of copper and zinc and boron. If we go towards the alkaline or more basic side, if we get to these extreme amounts, you have phosphorus, potassium, sulfur, boron, molybdenum. It's not ideal, so you want to make sure that your soil is within a good range. Also, this brings up a good point of if you're going to make additions to your soil, you can over add. If you add too much of any of these things, it can be toxic for your plants. There's a balance to be made, so that's why it's hard to guesstimate some of these additions to your soil. It's important that you actually send in analysis to a lab, get a number, figure out the calculations for your addition, and then spread that over how many acres or whatever you're working with, right, for your block. This is just a nice picture of what iron and manganese toxicity looks like. Very sad. The leaf starts to yellow and develop these brown spots, and just having a hard time. So not ideal. So on the other side of pH of soil, right, we talked about a low pH. At a very high pH, you get mineral nutrients, iron and zinc become less available, and this can create iron chlorosis and other nutritional problems. So here we have a picture of iron chlorosis and a grapevine leaf. It actually looks quite pretty, but it's not normal for a grapevine leaf to have these this variegation in green color. It's much more normal to have a solid green color on the grapevine. So that is an iron chlorosis problem. So not fantastic. So to measure the soil pH, we use a pH meter. I'm assuming it's a specialized meter for soil, but we can do this a couple different ways. One is with the meter, right? And I have a bunch of links on this slide, so if you'd like to read more about soil pH or correcting soil pH, we have that available for you. So you'll collect a soil sample with like a shovel or something, submerge the sample in DI water You'll mix it up really nicely, and then you'll use a special soil pH meter to measure the pH of the liquid in suspension. So all the ions from the soil will leach into the water, and then you'll be able to get a reading off of that. The other way you can measure pH is through a color indicator, and this is a very similar process, but instead of using the pH meter, you're using a chemical that turns the water a specific color, and then you compare that color to a chart, and then you can determine the pH of your soil that way as well. So both are good. If you're trying to establish a vineyard for a business, the pH meter is more accurate and much more precise. If you're just trying to decide if you need to fix the soil in your garden, the color indicator will work just fine for you as well. So it's just nice to know there's different ways of doing that. So if you wanted to change the soil pH, if you wanted to increase the acidity, also known as lowering the pH, you would add gypsum, sulfur, and organic matter. And there's lots of different things you can add to your soil to increase the acidity. To decrease the acidity, lime is added to soil. And these are all things you can easily get at your garden center and work with at home. If you're working on a large-scale agricultural operation, there's businesses and resources for that as well. Cool. So on the same page as soil, it turns out that the texture also affects nutrient availability. So in the last lecture, we talked about compaction. We also talked about pores and water drainage and oxygen availability and the ability for roots to move through, small holes that bugs have made, and how porous soils are better for plants in general. So all these wonderful things, right? So as far as nutrient availability specifically, it's kind of like the one extra layer to that information, right? So here we have sand, loam, and clay. And I know loam is a combination of different textures, but this is just what the textbook had laid out. So no, that's not meant to be silts. The textbook specifically said loam. For sand, we have large pores, right? Water flows through it pretty quickly. So low water retention, you would need irrigation for your vines, right? So because of this, nutrients easily leach through the sand. They're lost. Nutrient availability at depth is poor. So it creates a stress on the vine in that way, right? Generally, sand has low levels of organic matter, and so this also leads to low fertility. And then also the cation exchange capacity is low, and I have a slide on cation exchange capacity next, so just wait a second for that one. I also put in a fun fact here, not because it's related to nutrients, but sandy soils are naturally phylloxera resistant due to high silicon content. So if you visit some local wineries in the area and winemakers or the vineyard owners will say, well, we have grapevines that are on self-rooted vines, they're self-rooted, and we don't have a phylloxera problem. You could ask, well, why is that? And some of them might say, well, we actually have high sand content in our soil, and phylloxera just generally doesn't like sand. It's not a very agreeable environment for them to live in, so phylloxera hasn't been a problem for us yet. So that could be a possibility for some of the local wineries. I have heard it before on tours, so now you know. Little fun fact. So sand, in summary, sand does not have a lot of nutrient availability, okay, because of the structure and other components. Our cation exchange capacity is low. The availability of nutrients is very low for grapevines in general, right? Next, we have loam. Loam is, the A student. It retains sufficient water for vines. It drains readily, but it also contains sufficient nutrients, and it's considered fertile soils all around. So good cation exchange capacity in loam. Clay, on the other hand, is kind of a special subject. It has lots of small pores, right? We've talked about this. Water is hard to drain. Water logging is possible for the roots, right? And there's also potential topsoil structural problems, like hard setting and crusting forming during all that compaction because the pores are so fine. The interesting thing about clay is that the cation exchange capacity of clay soils is actually very high, but it doesn't lend itself helpful to a grapevine because you think of it as magnets, right? If it has a higher ability to attract these ions to itself, but it's such a tight bond that it doesn't want to give it away to the roots of the plant. So it's not actually available to the plants to consume. So even though the cation exchange capacity is high, it's not fantastic for grapevines. And then here we just have a visual aid, right? Sand, silt, and clay, right? Okay. Cation exchange capacity. So cation exchange capacity, also known as CEC, measures the soil's ability to attract and hold positively charged nutrient cations. So this is the soil's ability to hold on to, these elements that provide nutrients to plants, but it's also like, what is their ability to give that to the plant too, right? So clay, because of its nature, is something that is covered in what we need to know is negative charges, and all these nutrients, most all of them are positively charged. So it's like a magnet, right? So positive and a negative come together and they form a bond. Whereas sand is only covered with a couple of negative charges, and so it has a lower capacity to bind nutrients. So nutrients will just leach right through it. They're not actually binding and retaining in the soil. So things that can influence the cation exchange capacity is the soil structure and stability, right? So organic matter, the soil structure, and also nutrient availability, the soil pH, right? So depending on the pH, some of these things might not stick as efficiently as they could because it's not within the right pH range. Soil's reactions to fertilizers and ameliorations. So this kind of goes with pH, right? So if you alter the pH of the soil with an amelioration or a fertilizer, you might be adding some kind of nutrient to the soil after that, but it's just not sticking because it's interacting with something else. So that's just a very, very, very tip of the iceberg on cation exchange capacity. I'm not going to make you do any calculations on CEC. If you'd like to read more, please check out this Purdue Extension article. CEC is a very important and very good topic, but it's a little more than I want to dig into for an introductory class with no prerequisites. If this was a chemistry-based course, we would move more towards that, but not at the level that we're currently performing at. Cool. Nutrient mobility. So nutrients differ in their mobility in soil, which affects their ability to be lost through leaching, right? We talked about cation exchange capacity and what's available in the soil and how the texture affects that, right? So now we're learning about just the nature of nutrients and how they move in the soil and how they're available or not available, right? So there's nutrients that are very mobile, so things that are put into the soil and taken up like almost immediately by the plant, right? They respond to it, they take it up, and they put it to work right away. Then there are less mobile nutrients, which are like micronutrients, which take a lot more time. They need to be banked into the vine, and they're used kind of like slowly over time. So they're not as mobile, right? So macronutrients are mobile, micronutrients are less mobile, right? So we're talking about macronutrients, we're talking about ammonium, potassium, calcium, and magnesium. Those are things that are taken up right away. For micronutrients, we're talking about copper, iron 2, iron 3, manganese, and zinc. And generally speaking, fertilization of mobile nutrients needs to be done more often than the less mobile nutrients. So it's because it's taken up right away, it's depleting those nutrients from the soil, and so we'll need more applications more regularly there. Mobile elements are more readily taken up the vines or leached, which is good. Immobile nutrients can be banked in the vine and utilized in the next cropping cycle, with ammonium as an exception, right? Because ammonium is more mobile, but this can be banked and used for the next cropping cycle as well. So this is the NH4 up here. Cool. All right. So that's so we've talked about visual ways to determine nutrient deficiencies. Now I've kind of talked about the big picture of soil and how soil and nutrient availability and how some nutrients are mobile, some nutrients are immobile, and timing of applications, and how soil structure and everything affects how it's available to the plant. Now we're going to talk about tissue analysis. So tissue analysis is so important because you take samples of tissue and you can actually see what nutrients are physically in the vine, right? So we talked about visually, how does the vine look? Soil-wise, what's available? Are there enough nutrients in the soil? And now we're looking at, okay, what's actually being taken up by the plant itself? What are they utilizing? What do they actually need now? So there's two different types of tissue analysis. Both are very important and they play different roles. So we have petiole sample and we also have leaf blade sample. So a petiole is the little stem that connects the leaf to the shoot of the vine, and then the leaf blade is just the beautiful leaf of the grapevine. So reasons that you would want to do tissue analysis is to troubleshoot, to confirm or deny a suspected nutrient problem with your grapevine. So if your grapevine's looking sad and your leaves are looking a little funky, like some of our other previous photos, then you want to take a sample, send it into a lab, and see if it's a nutrient deficiency or a virus or a disease. You're going to want to know that so you can save your crop, right? You'd also want to take samples if you wanted to monitor your nutrient levels and to detect a nutritional problem before it negatively impacts the yield and fruit quality, right? So you could think about this like when you go to the doctor and you get a blood test, right? You're like, oh man, I've not been feeling good. I just want to see if I'm, deficient in anything, like check it out. They take a blood sample, they run your blood sample through the lab, and they say, hey, it turns out you have low iron. So now you need to take an iron supplement or you need to eat more red meats. Great. So it's a lot like that, right? So you might feel a little bit off, but otherwise you might be like mostly okay, physically fine. You can still get up and go to work, but you don't feel right inside. So having that testing so you can know and alter and then be at your 100% is kind of what that's like. So that's why you'd want to know. The grapevines might look fine, but it's good to monitor every once in a while. Okay, so if you're going to sample for tissues, whether it's petiole or leaf blade, it's important to do your sample at specific times, right? So there's two pivotal times in the growing season that grapevines will really need nutrition and that you should sample to determine that nutrition. So the first is bloom. So this is about when 2/3 of the flowering caps have been shed. It's also been referred to as full bloom too. So whatever works for you, just be consistent, right? So this is important because insufficient levels of micronutrients at bloom can have season-long effects on fruit quality. So we talked about like boron affecting like the hens and chicks, right? So that would be a time to know like, hey, like my micronutrient of boron is really low and I'm going to have a hard time, producing consistent berries that do well and ripen at the same time. Then that'd be a very important time. So bloom time, and then also veraison. So depending on your grapes and where you live, it could be mid-July to mid-August. This is huge because this is when lots of physiological changes are happening to the grape itself and also the vine, right? So the vine has decided to switch off vegetative growth. So all the growth for, like leaves and new shoots, and now it's switching metabolism. It's turning into producing lots of sugars for grapes instead. So they're actually remobilizing macronutrients, especially potassium, to make sure that the fruit they're producing sugars for the fruit to make it tasty and sweet, so that something comes in and eats it and then disperses the seeds somewhere else, right? It's all part of the reproduction cycle. So lots of changes happening there. You're going to want to know if your plants need more macronutrients in the situation to produce good fruit. So very important. Interestingly enough too, if you have like freshly like young planted vines, they should be sampled every year for the first 3 to 4 years, especially if you're new to the variety or the rootstock or just to the practice in general, so you can understand, hey, like let's say I planted Petite Arvine, which is a rare Swiss variety, and no one else in my area grows that, and I don't know how it's going to react to my vineyard. I need to make sure that I'm sampling this vine so that way all this money I spent on planting these 1,000 grapevines go into making it healthy and getting it off to the right start as it starts to settle in this new environment. So it's important to keep track of that stuff. Okay, so differences in petiole versus leaf blade sampling. So petiole samples, you think about the petiole, it's the stem, it's like a highway of nutrients going from the vine to the leaf itself, right? So photosynthesis happens in the leaf, and then it produces sugars that go to the grapes, and we go back and forth with water and nutrients as the leaves are like the powerhouse of the vine, right? So for the petiole, it shows the movement of nutrients towards the leaf blade. So this is a measurement that's very sensitive to the status of mobile nutrients. So we're talking about macronutrients here: nitrogen, phosphorus, potassium, magnesium. So mobile nutrients will actually move from older leaves to the newer growth. So deficiency will appear in the older leaves first. So that's where you'll see that. On the side, and we have an example here, of potassium deficiency. So you'll see a scorching along the leaf margins of mature vines if you have a potassium deficiency. Next, we have the leaf, sampling the leaf blade. So if you sample the leaf blade, it'll indicate the overall status of all nutrients, so including mobile and immobile nutrients like calcium and trace elements of manganese, zinc, copper, and boron as well. So immobile nutrients are incorporated in older vine tissue, and these will show deficiencies in the growing points first. So because the older parts already have those nutrients and the new growth is growing without those nutrients because there's now a lack of those nutrients, you'll see it on the new growth first. So this is a really good example. This is a zinc deficiency. So these are really young grapevine leaves. They're just starting to grow out here. You can see the shoot coming out this way and how the leaves are so tiny. They look so frail, and they're starting to show chlorosis. So those light green among the dark green parts, right? So it's very stunted growth. It's showing chlorosis. That is a deficiency in the young growth of the plant. So that's where that deficiency is going to start showing up, is there. So depending on what part of the plant is showing problems, you can determine if it's a mobile nutrient or it's a macronutrient, if it's on the older part of the more developed part of the leaf, or if it's a micronutrient potentially, which is showing on the newest growth, the youngest parts of the plant. So very interesting. Cool. So nutrient concentrations will fluctuate during the growing season, right? So the vine is switching metabolisms from vegetative growth to fruit development and responding to environment and taking in water during irrigation and then going through periods of water stress and dehydration. So lots of things are going on, right? So nutrients like nitrogen, phosphorus, potassium, and zinc tend to decrease in the growing season, right? And a lot of that's going towards, like we said, vegetative growth, berry growth and development, and photosynthesis function. So if you take vine samples, you can help track any deficiencies, so proper fertilization applications can take place. So here's just another nice table from the textbook. Shows you what will decrease during the growing season, what are stable and you shouldn't have to worry about, and what increases during the growing season, generally speaking. Cool. So, site selection. This is how you determine where to take tissue samples from. So any sites that will differ in the grape varietal, so the type of grape that you're growing, soil, vine appearance. If part of the block looks healthy but part of it doesn't, sample the block that doesn't look good and compare them side by side, you know. Also, your cultural practices. If you decide to dry farm block A but use regular irrigation for block B, and you're trying to determine if dry farming can be successful for your property, then take samples of those two different cultural practices, right? So whatever you are trying to determine, make sure you're taking samples. How to take samples. If you're troubleshooting issues, sample the leaves that are showing symptoms, right? If it's turning to yellow, develop spots, it's turning purple, it's turning red, whatever, sample the leaf blades that are showing those symptoms, regardless of their position. If you are sampling at bloom, you're going to want to collect the petiole and leaf associated opposite of the first or second flower cluster from the bottom of the shoot. So you'd be looking at the petiole and leaf across from the flowers that will become a cluster, right? So you'd be looking at either this leaf or this leaf. It's important to know that you shouldn't pick more than one petiole per shoot, because you could be affecting the ability for that cluster to ripen. And also, do not sample petioles connected to heavily diseased, insect, or mechanical damaged leaves. So you're not going to, unless you're trying to find out what's wrong with that plant, stay away from those, because that won't be an accurate representation of like the total block's nutrition. If that's just like a one vine got hit by a tractor or something, then obviously don't sample from that one, because it doesn't represent your full vineyard or full block. Cool. If you're going to sample at veraison, it's important that petioles should come from the youngest, fully expanded, mature leaves on the shoot, usually 5 to 7 leaves back from the tip of the shoot. So this is the tip of the shoot here. You're going to want to count back. You're going to want the fully expanded, mostly matured leaves. These smaller ones are not where it's at. So 5 to 7. There's also more directions if you want to know specifically on page 175 of the Grape Grower's Handbook. Cool. So once you take your petiole and your leaf blade samples, you send it to the lab and you get some results back. Depending on if it's full bloom or veraison, you'll get your nutrient analysis, and you can see the ranges of what's expected during those parts of the year, and whether or not you fall within those or not. Cool. So now we have our learning objectives. We have 2 slides for the learning objectives for this presentation. If you have any questions, please feel free to send me an email, or we can go over it in class. I highly recommend you read Chapter 16, Grape Grower's Handbook. I basically outlined, like I said, most everything from the textbook. It dives more into specific deficiencies and signs of things. There's a whole section on, what nitrogen deficiency looks like, and what, aluminum toxicity looks like, and so forth. So if you would like to learn the specifics of that, check out Chapter 16. Like I said, it's a great resource, and I might continue using it for more lectures in the future. So yes. All right. Well, thank you for watching. Study up, and good luck on the quiz.